Millions of people perform this ritual every day. You open a dark browser window, watch the spyglass icon appear, and feel a sense of digital seclusion. The assumption is that this mode hides your activity from hackers, government agencies, and your internet service provider. However, the technical reality of how browsers handle data reveals a significant gap between what the interface suggests and what the software actually delivers. To understand why that gap exists, we have to use the same framework as cybersecurity professionals: threat modeling. This is the process of identifying exactly who your adversary is before choosing your defense. When we apply threat modeling to private browsing, we see that the software was never designed for global anonymity. To see where it fails, we have to look at who is actually watching the connection. The most basic threat in any model is physical. This is a shared family computer or a smartphone left unlocked on a desk. For this specific scenario, the architecture of an Incognito tab is straightforward. The browser creates a temporary, isolated folder on your device's local drive. When the window is closed, the browser triggers a local wipe. It deletes the session history, removes local cookies, and clears out session storage. This functions as a hide from my family mode. It is designed to stop the person who physically uses your device next from seeing your previous searches. While this local digital broom is effective for physical privacy, the security it provides stops the moment your data leaves the device. But the second your data enters the wider network, it becomes visible to an entirely new set of observers. If you are on a university or office Wi-Fi, the network administrator has the tools to pull real-time traffic logs from your device, regardless of your browser settings. Your internet service provider routes traffic using the domain name system, or DNS. Think of DNS as a public directory. Your device sends a plain text website query that the ISP reads. Because Incognito mode lacks encryption, the ISP permanently logs every domain you visit. Because private browsing is a client-side tool, it lacks the architecture to interfere with this layer of network surveillance. Even if you could bypass the network observers, your data eventually reaches the final destination, the servers of the websites you visit. Web developers no longer need local cookies to identify you. They can see exactly who is hitting their servers through more sophisticated methods. This is browser fingerprinting. Websites query your device for its screen resolution, operating system, and installed fonts. By combining these hardware details with your IP address, the site creates a unique identifier. This fingerprint recognizes your device entirely without cookies. A private tab does not change your hardware configuration or mask your IP address. The fingerprint remains the same, and the tracking scripts continue to function. As web tracking has moved from local files to server-side analysis, the primary defense offered by Incognito mode has become largely obsolete. Using a local cleanup tool for network-level privacy creates a false sense of security while leaving your data exposed. Actual privacy requires a different architectural approach. You must encrypt your traffic before it ever leaves your machine. This is the role of a high-quality virtual private network. A VPN masks your IP address and wraps your DNS requests in encryption so the ISP cannot read your destination. For those requiring higher levels of anonymity, the Tor network offers multi-layered routing, passing your data through 3 different encrypted nodes to obscure its origin. The spyglass icon indicates a local cleanup script. To achieve true digital anonymity, stop treating a local script as a network shield and use the tools built for the job.